Hello, this is section 4.3 for Calc survey, and today we'll be talking about global extrema, global max, and a global min. So basically and you'll notice it says global or absolute. It is literally the highest and lowest you go. So if you are on a closed interval, and that's what this extreme value theorem states, if you're on a closed interval and everything is continuous, functions continuous on A and B, you are guaranteed a global max and a global min, and you might have more than one, okay? Now, when you're on an open interval like this graph, you can see you don't have a global min, but you do in fact have a global max. But the key thing is the global max is the highest and the global min is the lowest within that interval. Okay, now to find global max and min, so to find the extrema of a continuous function on a closed interval, you're going to evaluate each of the critical numbers. So you'll notice within that closed interval, you have two contenders that are within that closed interval. And those happen at the critical numbers when the slope of the tangent line is 0, or the critical numbers, remember when the slope of the tangent line is undefined, you might have a cusp or a sharp turn. So you need to figure out, are there any critical numbers within my region? Because those are contenders to be a global max or min. So that's what it's saying here. Evaluate f of each of its critical numbers. So once you've established the critical numbers, then you're going to plug in the endpoints and the critical numbers back into the function to determine what the highest and what the lowest values are. Okay, and that's what this all says. All right, so let's see one. So what is the global max of our function on the closed interval from 0 to 3? All right, so notice when I went to make my number line, so there, I jumped ahead. Find the derivative, set it equal to 0. These are your critical numbers. So on this function, these are where the interesting things are happening, right here. So I go over here and I created a number line, or you could actually just write out your points. You might do a candidate test. It doesn't matter how you do it. But notice I put closed intervals at my endpoints, 0 to 3. And then are any of these critical numbers within the interval I care about? And the answer is yes, 2. I don't care about -2 because it's outside of the interval I'm looking at. So I put 2 on my number line, then test these values in the original function. And you can see at 2, it's -16. That's your global min. And then the highest number, 9, so 3, 9, that's your global max. So you're plugging these critical numbers and the endpoints into the function, and you're just picking the lowest number, the lowest value is your minimum, the highest is your maximum. That's it. So you don't even have to check the intervals to see if you're increasing or decreasing. All right, so what is the global max and minimum of this function on this closed interval? Okay, so get your critical numbers. Where are interesting things happening on this graph? So that's the first thing I did. I found the derivative, factored out, so I could easily set it equal to 0. And these are my critical numbers. Okay, now I create my number line with the endpoints here, -3 and 1. Then I look and see, are any of these critical numbers within the interval I care about? And the answer is yes, -2 and 0. I don't care about -5. It's outside of the interval I care about. Now, test these numbers in the original function. So you're plugging all your critical numbers and the endpoints into your original function just so you can pick out the highest number and the lowest number. So you can easily see 216 is definitely your global max. So at 1, 216, and then 0 is your lowest number. So that's your global min. And that's it. So definitely easier than the first or second derivative test or determining inflection points. You're just literally finding where interesting things are happening in your endpoints and plugging them into the function to pick out the highest and the lowest number. And then just make sure you label them. Okay. All right. Please make sure you do your homework and let me know if you have any questions.